Hello everyone. Today I'll be presenting on my research work on named entity based sentiment analysis of Nepali news media text, where we try to distill the outlook expressed toward Nepali politician in Nepali news media text. This research was carried out by me, Virat Baji Shrestha, along with my professor Dr. Balkrishna Bal, Department of Computer Science and Engineering, Kathmandu University. Before proceeding with the presentation, I would like to express my sincerest gratitude toward the Asian chapter of ASIAL as well as NLPT for providing us with an opportunity to present our research work. Moving on, these are the basic outlines of my presentation. My presentation is divided into 5 sections. The sections are introduction, methodology, significance of research, conclusion, and limitation and future work. Introduction. So let's discuss what sentiment analysis actually is. Sentiment analysis is a subdiscipline of natural language processing that deals with identifying and classifying subjective opinions expressed in a text. The opinions expressed can be simple sentiments such as positive, negative, neutral, or complex emotions such as happy, sad, excited, etc. There are many ways in which sentiments can be analyzed from text. For our research work, we have used a specialized form of sentiment analysis called named entity-based sentiment analysis. Named entity-based sentiment analysis deals with finding the sentiment expressed with regard to a named entity. A named entity is a real-world object present in a text such as name of a person, name of an organization, name of a place, etc. For our research work, the concerned named entities are the name of Nepali politician. As a source of our research work, we have used Nepali news media scraped from Nepali online news media portals. The reason we have chosen news media as our resource is because they are easily accessible, widely available, and offer a variety of opinions. Methodology. This section details how we actually carried out our research. First of all, we came up with a natural language processing pipeline that is suitable for a named entity based sentiment analysis. The natural language processing pipeline we propose consists of 5 phases. The phases are preprocessing, part-of-speech tagging, name entity recognition, pronomial anaphora resolution, and sentiment analysis. Once each phase of the pipeline were identified, we studied the available literature in order to find the most suitable algorithms as well as tools and techniques that is to be used in each phase of the pipeline. Then we developed a framework based on the pipeline to perform the required training, testing, and evaluation. This is the system architecture of our framework. Initially, we set up a scraping framework that scrapes news media articles from available online news media portals and saves them into a database. Once enough number of news articles were scraped, we plugged those news articles into our natural language processing pipeline. All the dataset that are used in each phase of our pipeline are either downloaded from available resources or labeled manually. Preprocessing. Our preprocessing phase can be further divided into 2 subphases. In the first subphase, the articles are cleaned by removing unnecessary HTML tags as well as unnecessary JavaScript codes. The second subphase of our preprocessing phase is article lemmatization. By studying the literature, we found out that for Nepali language, most of the word inflation is caused by the postposition suffixes, and by lemmatizing those postposition suffixes, the performance of our entire framework can be improved. Based on these facts, we developed a dictionary-based suffix stripper. What this suffix stripper does is it will scan a word, and if the word ends with a postposition suffix, it will split the word into its root word and the postposition suffix. The postposition suffix aren't removed from the text entirely because they are necessary for the subsequent phases of our pipeline. Part-of-speech tagging refers to the process of assigning a lexical category to each word in a sentence according to its grammatical role. The most common part-of-speech tag of English language are noun, verb, adjective, adverb, pronoun, etc. For this work, in order to tag the part of speech, we have used trigram and tagging, also known as TNT. In order to train the model, we have used the corpus provided by Center for Language Engineering. For this phase, we were able to uh, achieve an accuracy of 90.05%, a precision of 96.55%, a recall of 91.03%, and the F1 score of 93.06%. Name entity recognition. As the name suggests, in this phase, the named entities present in a text are recognized. A named entity is the real world object such as the name of a person, name of an organization, name of a place, etc. In order to recognize the named entities, for our research work, we have used conditional random fields, and to train the model, we have used a corpus provided by Singh et al. For our For this phase, we were able to achieve an precision of 92.5%, a recall of 81%, and an F1 score of 86%. Anaphora resolution. In the anaphora resolution phase, the expression that are referring to or named entities are resolved. In order to resolve such expression, the pronouns and other part of speech tagged by the part of speech tagging phase and the named entities tagged by the named entity recognition phase are used. In order to resolve the anaphora for our work, we have used a rule-based method based on Lapin and Leash algorithm. We have made changes to this algorithm so that it is better equipped for handling Nepali pronomial anaphora. For this phase, we were able to achieve an accuracy of 87.45%. Once the process of anaphora resolution was complete, we extracted all the sentences which consisted of a name of a Nepali politician. Such sentences were used in a subsequent phase of sentiment classification. Sentiment classification dataset. Initially, we searched the internet in order to find a dataset that could be used to train a sentiment classification model for our work. But unfortunately, such a dataset could not be found. Therefore, we labeled a dataset manually ourselves. We labeled 3,490 sentences. Out of those 3,490 sentences, 2,676 were positive and 814 were negative. In order to make the dataset more balanced, we kept the same number of negative as well as positive sentences in the dataset. Therefore, our final dataset had 1,628 sentences with 814 positive and 814 negative. Embedding. In order to embed the text for feature extraction, we have used two models. The models are word2vec and fast text. Each of these models represent each word from the entire corpus in a 300 dimensional vector space. And for sentiment classification, we have experimented with three machine learning algorithms. The machine learning algorithms we have experimented with are support vector machine, random forest, and decision tree. From our experimentation, we found out that support vector machine, when the embedding technique word2vec was used, was performing the best with an average accuracy of 80.59, precision of 80.45, recall of 80.7, and an F1 score of 80.5%. So, as an application of our research work, we presented the popularity trend of Nepali politician in a time series graph. This graph shows the popularity trend of three of the most prominent Nepali politicians. It shows the popularity trend of KP Sharma Oli in blue, Pushpa Kamal Dahal in orange, and Sherbadur Dewa in green. Significance of research. We were successfully able to implement a natural language processing pipeline for sentiment analysis of Nepali text. This research can be a basis for future research in the field of sentiment analysis of Nepali texts. This work can also be extended into a more fine-grained approach such as aspect-based sentiment analysis as well. Other significant contribution of this work include a lematizer for Nepali text, a rule-based anaphora resolution for Nepali text, and a sentence-level sentiment annotated dataset of 1,628 sentences. Conclusion. So the goal of our work was to uh, develop a named entity based sentiment analysis. In order to do so, we proposed a sentiment analysis pipeline with 5 phases. As a application of our research, we presented the popularity trend of Nepali politician in a time series graph. Such graph can be of interest to the political leaders themselves, the parties the political leaders are affiliated to, as well as the media house and general public. From our experimentation, we found out that word to wake was the optimal choice for word to word embedding, and support vector machine was the optimal choice for sentiment classification. Limitation. In the anaphora resolution phase, only pronouns were resolved. Other expressions that were referring to or named entities were ignored altogether. Future work. So the performance of our entire framework can be improved by using specialized variants of neural networks such as recurrent neural network, long short term memory, and bidirectional long short term memory. We have already seen the use of such neural network for participant tagging, name entity recognition, as well as sentiment classification. The best bet at the moment for anaphora resolution seems to be graph-based neural network, as they are better equipped for handling non-linear data. Furthermore, modern embedding techniques such as Barton-Elmo can be used to more accurately embed the context of a word within a sentence and get a better overview. These are some of the references of our work, and I would like to conclude my presentation. Thank you all for listening.